Looks like it's okay. And go ahead, Mark. We're recording and we're ready to go.
All right. Thanks, Doug. Well, welcome everyone to the Seven Ponds Astronomy Club June 11th meeting. This is our first ever in-person / Zoom meeting combination, and our first in-person meeting since, I believe, February of 2020. So thank you everybody who's there at the Nature Center for coming in person. Next, please, Doug. Just a little bit of miscellaneous information here. If you would like to contact the club, you can contact us via our email, spncastronomy@gmail.com. You can message us on Facebook by searching Seven Ponds Astronomy Club, or you can even message us on our website. If you Google Seven Ponds Astronomy Club, it has a message feature. And if you're there at the Nature Center, please remember to sign the guest book that probably the planning committee people have on the table near the kitchen. That's very important as we use that to report back to the Nature Center our attendance, and then they use that for obtaining funding and stuff like that. Next, please, Doug. Okay, so our coming events, we have suddenly quite a number of events posted. July 10th is going to be, I forgot to put his name. I hope he's not there. It's Don Glazer. And let me try this pronunciation. It's called the Antikythera mechanism, which is, they believe, the first ever computer that was used for astronomical forecasting, and it was found off in the ocean off Greece on a shipwreck, and believed to be several thousands of years old. Next up is July 16th is the Attica Day Festivals up in Attica, Michigan. The club is going to be offering solar observing to attendants for the fair, but we also get to do the fair stuff ourselves, which includes music, a beer tent, and kids activity, and a whole lot of fun things. So we always need people with solar capable scopes to meet us up there. So if you're interested, just let one of us know. And again, that's July 16th at Paul, I believe it's Attica Township Park. If you head over to the website or Facebook, it has the address for that. August 5th and 6th is another Attica event called Astronomy Over Attica. That's going to be an outreach event. I believe it's scheduled for the 5th initially, but it depends on which day is the better day for night sky observing. That's going to be at the Attica Township Library, and we're going to be providing telescopes for night sky observing to the attendees. And there's kids activities and crafts. If you're coming only for the program, not bringing a telescope, you'll have to register with the library. That's so they can plan on the number of people that they expect. August 13th, the Ford, I forgot what FAAC stands for, Doug. Ford Amateur Astronomy Club, correct? Okay.
Correct. Correct.
All right, thanks. Tim Campbell is going to present Spectroscopy, the gift that keeps on giving. This is going to be in person and in Zoom, just like we're doing now, except that Tim will be at the Nature Center in person. And he does some kind of hands-on stuff, which is why he wanted it to be in person. So next, Doug. September 16th through the 17th is not a Seven Ponds event, but it's a multi-club event called Astronomy at the Beach, Michigan's largest public outreach event. And takes place at Island Lake Recreation Area near Brighton, Michigan. And it's a great event. It's back in person this year, I think, after 2 years of being online. And there's lots of telescopes and lots of people. And it's a great event if you want to bring a telescope or if you just want to attend and look through all the scopes, then you're welcome to do that. September 22nd through the 25th is the Great Lakes Stargaze. That's Michigan's largest star party up at River Valley RV Park in Gladwin. And it's a really great event. You can camp there or you can stay in local motels and hotels. And it's a whole lot of fun. October 3rd, Mike Close of the Seven Ponds Club is going to be presenting a binocular presentation and details of TBA and that. We only have the date set. That's also going to be in person and in Zoom. Okay, tonight we have the great imager Doug Bock presenting beginning Astro-Imaging. Doug is a past president and vice president of the Warren Astronomical Society, former editor of the Warren Astronomical Society newsletter called WASP, member of the Warren Astronomical Society, Ford Amateur Astronomy Club, the Lowbrow Club in Ann Arbor that's affiliated with the University of Michigan, and our own Seven Ponds Astronomy Club. Chairman and vice chairman of the Great Lakes region of the Astronomical League in the early 80s, owner and operator of the Northern Cross Observatory. He's retired from Ford Motor Company at the end of 2018. Congratulations again, Doc. And he has 41 years IT and real-time system specialist. And he's a great astro imager. So with that, Doug, thank you for joining us, and you can take it away.
You give me credits where I don't think is due, but that's okay. uh, okay, let's get started here. Beginning astro-imaging, and then I'll be going over several things in here, but a little back history is I started astro-imaging actually back in around 19. Well, my first imaging session was in 1974 when I was using the MSU 24-inch Ritchie-Chrétien there at the observatory on campus, and they actually paid me to do astrophotography and spectroscopy at the observatory. And so that was my first exposure to deep sky imaging and processing of 4-inch by 5-inch glass plates with basically black and white with an emulsion called 103AO, which is kind of a red infrared sensitive emulsion. And so that was my first astrophotography back many years ago. And then it was about 1978. I got my first camera for a regular single lens reflex camera with 35 millimeter film, and I had already built a couple of 8-inch telescopes, so I started doing some astrophotography on film back then. So that's a little bit of my early history. But basically, what I'm going to go over today is things that I've done just in the last 9 years. No, let's see, 8 years. Since 2014, I started doing some simple astrophotography again with a DSLR, which is what a lot of people use nowadays, and that's what we're going to go through to start with here. So the agenda is doing some simple setups, and then I'm going to go through some slightly advanced setups, and then I'll show you some examples of those results using the simpler setup, and then I'll talk about some tracking systems and some example results of that, and then time-lapse photography, and then some processing software, and then I'll talk about some of the advanced systems I currently have that I'm using to do deep sky observing or deep sky imaging. So the simplest setup is with a tripod and a DSLR if you have one. If you don't have one, you could do you can get a DSLR that allows you to do longer exposures using the bulb setting or the long exposure mode setting. In this case, I've got a Canon T3i set up on a tripod. It's a digital camera. Currently I use a 10 to 28 millimeter lens for wide field. Then there's a device called an intervalometer, which allows you to run the camera remotely, slightly remotely, with no hands on it, and program up a sequence if you want. I have a dew heater strap that I use on there, and that's to keep the dew off if you're running a time lapse all night long. You want to be able to keep your lens clear of dew or frost depending on the time of year. And then a power supply for both the camera and the heaters. And I use in the backyard, I've got 110 power, so I use that to run the camera. I can also run a power supply to run 12 volts to the heaters if I want, but I also got batteries, so sometimes I use those to just run the dew heaters. You'll want a comfy chair if you're going to sit out there for a while, and your favorite beverage, whatever that may be. No judging here. And of course, you'll need some clear skies to do this. And this tripod is set up is on a got a 6 foot cement slab out behind the observatory, and I got power off the observatory. Allows me to do this in the backyard if I want, or I can do it up north or wherever. Very simple setup for traveling. In fact, if you want to just do some interesting things with lightweight uh, a lightweight setup. So this is an interferometer, and it's designed to allow you to set up how many exposures you want to take from one to basically forever until the battery dies. How long you want to take your exposures, 15 or 20 seconds, depending on the lens and the configuration of the camera. In my case, I use it most of the time. I use it at 15-second exposures at ISO 6400. At least that's what I did early on. I've kind of made a little bit of changes recently, but I'll go over that a little bit. You set the intervalometer to take number of frames you want. Put a pause in there to between frames, 5 to 10 seconds, to allow your DSLR to cool down a little bit, because while it's exposing for 15 seconds, that amplifier is getting warm, and it sets up a lot of thermal noise on the chip itself in the camera. And you remember that DSLRs are not cooled, so you can't regulate the temperature on a DSLR, and that has side effects downstream when you want to do processing on it. It's difficult to get rid of the noise level. Or you can just trigger the single shots by holding down the button for the time duration. You can just that little button right here. This little button right here allows you to hold it as long as you want. You can lock it in place, so you can take 2 minutes if you want. You'll get star trails at this focal length if you go a couple of minutes, but it allows you to manually take it. Otherwise, you can just set it up to go with the configuration. The amount of time you can expose without trailing stars depends on the focal length of the lens you're using. There's a thing called the 500 rule, which will get you in the ballpark. For example, with a full frame camera and a 20 millimeter lens, it's 500 millimeter. 500 divided by 20 millimeter lens is about 25-second exposure. That's about the max before you're gonna see some trail. You'll see trail anyways if you zoom really close in, but that basically is not too bad. You may still get a little trail, which you could see if you zoom in a final product, but it's not typical detectable in normal computer screens. And you have to remember that these exposures you take with any of these cameras nowadays, they're so large, 6,000 by 4,000 pixels. When you display them on screen, you're not displaying all the pixels anyways, because unless your screen is 6,000 by 4,000 pixels on the screen itself. So it's usually software on computers only display to the resolution of the display screen, even though you got more data sitting there. So that's something to keep in mind. So experiment with the various lenses, exposure times, and gain settings, or ISO, to find your sweet spot for what you're working on. So here's an example of a dew heater controller and a dew heater strap that's hooked to the lens. And that's just, again, just to keep the dew or frost off your lens when you're running out in the at night. As you know, the temperature drops quickly when you at night, and it gets close to the dew point. You'll get moisture on your lens, and in fact, you'll get moisture on just about anything that's very dark first, and then very light later. But that's just it's funny. The story I'd give you is that I've been down in Texas at the Texas Star Parade, and people wonder what those straps I had on my telescope were. And I just they're dew straps for dew heaters. What? Dew heaters are absolute must here in Michigan. So a bunch of straps and controllers out there in the market, and you can just pick whatever you feel is reasonable. Some people use actual chemical hand warmers with rubber bands to accomplish this. You crack it open, you wrap it around the lens with a rubber band, and it'll keep it warm for several hours. So that's even an option. So you start doing this long enough, you start thinking about, I wonder if I can control this with a computer instead of my little intervalometer. Well, yes, you can. So the next step might be to run an entire night of images for a time lapse video unattended. In other words, you can start it up or sit there for a couple hours, but then you can go to bed and let this run all night long if you want under computer control. So it can be done with the envelometer as well, but also with a laptop. And the connection to the laptop is usually a USB cable, but in some cases cameras have built-in Wi-Fi, so you can connect them in that fashion. And the laptop can be used with various software to set exposure time, ISO, and more importantly, remote focusing. The focusing remotely allows you to tweak the camera lens without touching it, which is important, and you can be more precise with that. Because you don't want to fiddle around with the little screen that's on the camera in your hands on the focuser when you can do it from a large screen on a laptop and a digital control. Much better to do that way. I happen to use a thing called Granite Bay time lapse software to run the entire night of images. This software has the advantage of changing aperture, exposure, and ISO automatically from dusk till dawn and creating a smooth transition from twilight to total darkness. And then once you start it up, you can leave it for the night. Just remember to have your dew heaters on and all night power for everything. I use shore power to run everything, but a generator would do, or a large capacity battery with inverters might do the job as well. As you bring more capability to the table fills up, and you need a bigger table. This happened to be up at Paul Latan's place in northern Michigan one weekend. We spent some time up there. So here's an example of a single frame with my Canon T3i, an 18 millimeter lens, and I just open it up for 15 seconds. And there isn't any special processing here. This happens to be a northern property shot. That's Cadillac in the east there. But you can see the Pleiades in the Hyades here. Here's the Pleiades right here, and then the Hyades, which is part of Taurus, the bull. And so you can get kind of some interesting things with a single frame. So here's another example of a single frame with the 18 millimeter lens with the Milky Way, and it was a few years ago. So Jupiter's over here to the west of the Milky Way that night, and this is up at my property up north. And that's just a single frame, no special processing, just basically a raw data. Here's another single frame at my property with the 18-inch Star Master Dobsonian we've got sitting up there, and I was running my camera that night as well. And this is looking to the north at my property. There's actually a 25-inch hiding in the darkness over here by this big tall ladder. But this is the 18. So this again, a single frame with an 18 millimeter lens, and looking north, so you can see the various constellations we've got here. Another night with the 18 millimeter lens. This is at Bill's place, his observatory here. This is the Warren Club's 22-inch. I'm standing here with my 14-inch, and there's a bunch of people in the field here. Again, another 15-second exposure, ISO 6400, and 18 millimeter lens. So you can do some fun stuff, simple stuff with that setup. Now this is with a 10 millimeter lens. This is at the Great Lakes Stargaze a couple of years ago, and some of you may recognize this individual here. He's the founder of the Seven Ponds Astronomy Club, one of the founders at least, of primary, as far as I know, John Lines. But this is up at the Great Lakes Stargaze, and he couldn't make it that year, so we put Johnny on a stick, and we took pictures of him everywhere. But in any case, that's Polaris there, and this is the field of view of the 10 millimeters, quite large. And again, this is just a 15-second exposure with the 10 millimeter lens using my T3i. Oops. Now, but you could also take this rig to Bortles 1 skies, very dark skies. And this is actually with the T3i, a 10 millimeter lens, ISO 1600, not 6400. and this was a 20-second exposure because I'm running only a 10 millimeter lens. And this came out pretty nice, just a single frame with the 10 millimeter. And then there's no special processing with this. I didn't push it real hard to bring out any of the H alpha regions in our Milky Way or anything. But you can see there's here's the horse, and we got Sagittarius right here, and this is part of Scorpius right there going down. This is Jupiter. This was last October, so Jupiter's now east of the Milky Way, whereas the other one I showed you was quite a ways, quite a few years ago, was west of. I'm sorry, was west. Yeah, west of the Milky Way. So this is down at the Okie Star Party. That was a great event. Now, the other thing you can do if you take a bunch of these is you can do what's called stacking and then process the data. So this happens to be with the same T3i, 18 millimeter lens. I don't know what that 2 is there. A typo. But it's 17 by 15-second subs. So I took 15-second frames and I stacked 17 of them together with some software and did some processing on it. And so you can now see you get a bit of depth with that and some color and some interesting looking image, if you will. So there is some stacking you can do, even with a simple DSLR and wide field lens here. I can let somebody in. And the thing about doing this now with just that simple optical setup is you're learning how to use the processing software, which is important because even if you're not using a telescope for this, you can learn how to use all the same processing tools for stacking and doing color calibrations, et cetera, that you would use later on if you ever go to a more advanced system. It's the same software, it's the same process, et cetera. It's just you're using smaller lenses to do it at this point. Another thing you can do when you're doing time-lapse photography is you can do some cool star trails. This happens to be with the 10 millimeter lens at the Okie Star Party last October. And this is 9 hours of data. I collected data for all night long. And these are the 20-second sub frames that I took. Each frame was 20 seconds with an ISO 1600 and the 10 millimeter lens. And there's a piece of software that allows you to take that entire series and create this star trail called Star Tracks. And that kind of is a cool thing to look at, I think. Plus, you get all the foreground movement of people running around with their red lights on, et cetera, et cetera. You can tell this is almost 12 hours because the curves are very large, almost 180 degrees. Not quite. It's 9 hours, so it's probably about 150 degrees curves. But you can also do this up at the Great Lakes Stargaze, for example, which is another example of the 10 millimeter lens. And this was approximately 6 hours of data collected during the 2019 Great Lakes Stargaze. And I used an application called Star Tracks to create these star trails. So using 6 hours and 15-second exposures stacked in the tool. And this was with the 10 millimeter. Another thing you can do with your camera on a tripod setup is you can take 15-second exposures all night long and you might catch a nice meteor with a little bit of aurora in the foreground. This is in my backyard facing north. A little bit of aurora there, got this nice meteor. And again, this is just with, this one happens to be with the 18 millimeter lens. And some nights I will do some meteor hunting and I will take 1,200 frames and I only get 13 meteors out of those 1,200 frames. So it's kind of a chance that you might get one. But aurora is really an interesting thing to get. Again, this is typically an 18 millimeter lens, or you can do the 10 millimeter. And these are 15-second shots as well. And I took a whole series of this aurora that night at my northern property in Boone. Some nice aurora there. And sometimes you get some interesting effects there. Same camera, same setup, single frame. This was back in 2016, I think. We had a really major aurora up there at the northern property, and this is just one of the many frames I took of that with again a simple 18 millimeter lens on my DSLR on a tripod. This was at Bill Beer's CW series observatory. That's his observatory in the foreground. But you can also do things like the moon on a tripod with a telephoto. Because it's so bright, you can take really short exposures. So you can put a 100 millimeter, a 300 millimeter telephoto on there for the moon, and take quick, 1/250th of a second exposures for lunar stuff. So this is an example of a simple one. I think this is probably 135 millimeter. But the next thing you might want to do is get a tracking platform. And the reason you would want to get a tracking platform is to compensate for the Earth's rotation. This will allow you to take longer exposures with that camera. This happens to be a Ioptron Sky Tracker drive system with a ball mount on top of it. The camera's not on there right now, but you just slide that camera on the slot on top there, and now your camera's being driven at what's called a sidereal rate, using the sidereal drive system on this thing. And then this particular Ioptron Sky Tracker has a polar scope, so you can align it on the pole to get it close to the North Celestial Pole. So when it's driving for your exposures, it doesn't drift in the deck. It stays tracking in the RA. And one of the things you can get is a simple application for your iPad or your iPhone, but it has the ability to set your location, your date and time, and then it will tell you where you should put Polaris on this ring that's in this polar scope. There's a grid. This grid is in this polar scope, so it tells you where to put Polaris at that particular time, at that particular longitude and latitude, on that particular date. So now you know you're fairly close to the pole when you do that. You can use other applications as well, but just happens to be the one I got from my Optron. And so the other thing you can do is you can use your telephoto on that tracker to keep up with comets and things like that, taking longer exposures. This happens to be a 75 millimeter lens on the Ioptron tracker. And I took 9 90-second subs and stacked it on the comet's core. There's a little bit of trail there because I actually stacked on the core. I stacked on the core of the comet. And the point I'm making is that each of the individuals have good stars, but if you track on the comet core using the software that I use, the star trails will show up because the comet itself is moving relative to the background stars over that time period. This is Comet Neowise, by the way. Another thing I took a shot was using my tracking mount and a 300 millimeter lens, the conjunction of Venus with the Pleiades a few years ago. And I stopped down the lens. That's why you have these spikes, because it's an iris that stops down on the camera, and it generates these diffraction patterns spikes that you see here. And this is the Pleiades, and that turned out to be kind of nice. Now some people remember there was a reflection artifact over here, which I've taken some software and basically masked out that reflection nebula, or that reflection of this star, this object in the lens, because you'll get lens flare on really bright objects. But this is using that tracking mount that I showed you, and I had a 300 millimeter lens. Now, some of the downside of using astrophotography tools that are like the DSLR is you'll get a lot of artifacts. This is 14 by 1 minute subs, and it's stacked, 14 frames stacked. And I put this up here so you'll understand something that you will see if all you do is take frames and you don't do what's called calibration frames. Those would be things like dark frames and light frames, etc. And what ends up being is you'll get amp glow from the sensor like we have down here on the right hand side. You'll get dust donuts like we have over here. Those are little particles that are on one of the lens surfaces somewhere in the optical train. The farther away the dust donut or speck is away from the sensor, the larger the donut is and the more diffuse it is. The closer it is to the sensor, the smaller the donut and the more prominent it becomes. So you only have to really worry about uh, dust particles that are relatively close to the sensor. I would say within 25 millimeters. But this is the Orion Nebula area, and over here is the flame and the horse head. This is I wanted to show, and the other artifact you'll get is vignetting. And so, what I wanted to talk about here is that you want to mitigate these darks or these artifacts by using what's called darks and flat frames. Dark frames should be taken to eliminate bad pixels during the processing of your images, and flat frames should be taken whenever you change the optical system to be used during processing to eliminate gradients from vignetting, dust donuts that exist from dust in the optical path that are close to the sensor. Darks you can get away with on cooled cameras. You can get away with darks for weeks or months at a time on cooled cameras, which I'll go over in a little while. Flats you have to take every time you change the optical system. So if you change lenses without taking flats, if you have a setup and you don't take flats and change lenses and you do some more, the first set of images you took won't have good flats because you've changed the optical system, which may have particles in different locations. So you want to take flats either just before you start your imaging run or just after you start your imaging run with a fixed optical system. And I say fixed optical system, that goes for um, camera lenses, telescopes, etc. But mostly if you're changing stuff down at the imaging end. Okay? Yeah, we may go through a little bit of that. But you can also take uh, some interesting stuff. This is up in the Cygnus area. This is the North American Nebula taken with one of my zoom lenses, and these are 1 minute subs stacked, 15 of them stacked. And there's the North American Nebula here, and the Pelicans over here. This was taken quite a while ago, so and this is with the T3i DSLR. I've got an image of this with my astrophotography camera, cooled, and lots more H alpha in that one than there is in this one. Oops. This happens to be in the Antares area. No, this is not. This is in the elephant trunk area with the 300 millimeter lens. And this was taken with 24 by 300 second frames using the Canon T3i with a 300 millimeter lens. Now this one happened to be piggyback on a tracking platform, my better tracking platform. It's got 2 hours of data. But the reason I'm showing it to you, even though it's on a better tracking system, is it's still with a T3i and a 300 millimeter lens. So you can still leverage your DSLR and your lenses, even when you're on an equatorial mount. That's a little more robust than that little tracker I've used previously. This is basically 2 hours of data. A lot of dark nebula in here. It's kind of a cool setup. This is the Antares area. Again, same kind of setup. A lot of exposure time, but it doesn't have a lot of H alpha because the DSLRs are not real sensitive in the red. So I want to show you the other thing you can do with a simple camera setup, like I showed you at the beginning, you can do a time lapse. And this is from the Okie-Tex Star Party last October. Again, the simple 10 millimeter lens set up on the tripod. It's not even on the tracker. It's just sitting there raw, and I'm taking 20-second exposures uh, at ISO 1600. So let me play this video here. Hopefully the audio comes through. This is facing south. Of course, that bright object is Jupiter. Oops, I pressed a button I shouldn't have. Yeah, no audio's coming through. But that's okay. Then this is facing north. Around, you can see we're rotating around the Polaris. Believe it or not, there's actually a red light there on that, even though it looks very bright. These 20-second exposures really bring out the lights. So this is something you can do with that same camera setup and running all night. I had the intervalometer running this, and I was sleeping, so it just ran until I had it stop. So let's talk a little bit about the software that I use. Um, for the DSLR camera setup, I use Backyard EOS to run the camera, or I use GB Timelapse to run the camera for all the data acquisition. And for processing, I use Deep Sky Stacker to stack multiple frames, only to stack, and that software allows you to put your darks and your flats and biases in as part of the stacking process if you want to use it. That's just a piece of information you can stack with all your calibration frames for later processing. And I use the PixInsight to process that data. I use Vegas Studio to create the time-lapse videos, and sometimes I will do some cosmetic work with GIMP 2.0, which is free. And then I also have a tool called Topaz AI Denoise. That is used once in a while to get rid of some noise on some of my images that I take, but not very often. So here's Deep Sky Stacker. Let's see, make sure, yeah, okay. This is Deep Sky Stacker. This happens to be an image of M31 raw data. This was taken with the um, with my refractor that I have. I used to stack multiple frames that you have collected, and this is where you select all your light frames, your dark frames, your flat frames, your bias if you want them, and then the light frames are the raw data you've collected. So in the case of a DSLR, they'll be in the case of my DSLR, there'll be CR2 files, which are the raw data. In the case of most of the astrophotography cameras, the cooled ones or even the non-cooled ones, they're called FITS files, and this will read both. Flat flames are used to subtract out the artifacts that I talked about, like dust donuts and vignetting. And then the stacking process is pretty simple. You select all your you open your picture files, then you select your dark files, you select your flat files, and then you just go down here and say register all the checked um, pictures. When it's done, it does what's called a debayering of the raw data, and the raw data is actually got four colors on it. It's got what they call red, green, and blue debayer matrix. on these one-shot color cameras like the DSLR or these one-shot color astrophotography cameras. They have a matrix of color, and that's how they create the color pictures. But when you stack them, you get basically this raw data set that's sitting here. Not too impressive, huh? Very, very unimpressive coming out of the stack. But don't worry. I got to let John Lyons in here. There we go. Um, that is what the raw data would look like even after it's stacked. But then we go to PixInsight and start processing that software. And the process that I use, um, you can use PixInsight stacking algorithms as well as the Deep Sky Stacker algorithms, but I found that Deep Sky Stacker was just simpler to use for stacking, not for processing. It doesn't do a very good job for actually doing post processing, but it's decent for Deep Sky. The Deep Sky Stacker is decent for stacking, but PI is very good at doing all kinds of stuff. I use these four basic functions all the time with a dozen other functions sometimes. It's got hundreds of functions in it, but I've come down to about a max of around a dozen functions that I use. There are some functions in PI that don't exist anywhere else that's convenient. One of them is comet stacking. It's much more convenient to do comet stacking in PixInsight than it is in Deep Sky Stacker. In this example, I pushed the blue channel a bit too far. I'm showing this because it may or may not be preferable. But you can do all kinds of things with processing tools. And the first thing I do is bring in that TIFF file from Deep Sky Stacker, and I apply what's called a photometric color calibration, which basically uses a database online. You tell it what object it is and the field of view, etc., and it determines what stars are in that data set that you're using right there, and what the color of each of those primary stars that it wants to use, what the correct color calibration is, and then it calibrates the image from that. There's other ways of doing it, but that's what I happen to be doing. And then I use something called the automatic background extraction, which does some gradient removal. That's the best way I can put it. It removes some of the gradients that may still be in there. So that's, and then I use the histogram to stretch it, and then I use the channel calibration or the channel uh, to just do some saturation work. I don't even move the RGB graph at all. I just use these two tools to do my stretching, and that's what I got out of M31. So this is an example of how I process my data. And there's an example with more neutral colors. And that's just this part of the hobby I call art, because people like to use different color balances and want to do more this, that, the other thing, whatever it is that they like to do. And I call that art using the processing tools that we have in our hobby. And that's part of the hobby. If you're going to do science, you're going to want to use monochrome. Let's say you want to do science, like astrometry, moving objects like asteroids and comets. You'll want to have a monochrome camera, and you want to have precise timing, so you can do precise measurements off the film or off the image to determine location over time. And that's part of the science. Or you can do spectroscopy. But most of the time, us amateur imagers do what I call art. So some of the hardware that I use in that setup is for all those previous images is a Canon T3i DSLR, and I use various lenses that I have. I have a 10 to 18 millimeter zoom, an 18 to 55, a 75 to 300, and then I have a 300 prime lens that I use also. I use the iOptron Sky Tracker, a sturdy tripod, and a good power source for either the camera and or the heaters and the tracker itself. The tracker can run with batteries inside it, but you can also hook up a 12-volt source to it. This is important for all-night data acquisition. If you're only going to go off for an hour, you may be able to get by with just batteries and maybe not even have to use dew heaters. So it depends on what you want to do. So if there's any interest in advanced systems, this happens to be an example of an advanced system that I take mobile from time to time, but also use in my observatory primarily. It is a 10-inch Ritchie-Chrétien telescope with a couple of astro cameras and my T3i piggybacked on the top. The mount is a Losmandy G11. This was at the Great Lakes, 2020 Great Lakes Stargaze. Just an example of what um, I am using right now. But you can get even more advanced, and you can build an observatory. I built a observatory in 1984, and it makes it much easier to have a setup ready to go when it is clear. You walk out, you open up the roof, you power everything up, and you're ready to go. In '84, we built this first roll-off roof on the left there, which was housed a 12.5-inch f6 Newtonian for observing, and also astrophotography with my film camera that I had on OM1, Olympus OM1 film camera. But in 2018, I tore it down and we built up a new one because the old one was getting kind of rickety, and my wife was worried about it falling on me one night when I'm trying to close it up. And so we've had a newer one built and with the 10-inch RC in it. Current options I've got in that observatory are this 10-inch f8 RC and the upper left frame shows a 4-inch f10 SET with a solar filter on it, so I can do solar filter with that telescope. It's a little 4-inch SETs I've had for 42 years. Or I can put the 300 millimeter f4 Canon lens on top of the bottom left corner. There is the Canon camera on top with the astrophotography camera on it, or the Canon lens. The cameras I use, I'm sorry, I also have a 105 millimeter f7 apo refractor in the lower right, and a 6-inch f10 SET in the upper right, which I also use for some planetary and my solar stuff with a solar filter. Some of the cameras I have are ZWO ASI 071 MC cooled camera. Their original 071 that came out in 2017. It's a cooled camera. It's about the size of a APS-C size chip like my T3i. And then I bought a couple of years later. I bought a 071 MC Pro, which had a little better noise floor and was a little faster on transmitting the data. And then last year I bought a ASI 2600 Pro, which has a very good noise floor. It's so low I almost don't need to take darks. Again, those three cameras are cooled so I can regulate the temperature. Usually run around 0 degrees Celsius. I have a Lodestar 2 camera which allows for my auto guider to run. And I have, of course, have the Canon T3i, and then I have a couple of security cameras in there, and then a PoleMaster camera, which is from QHY. The PoleMaster camera is designed to allow me to do polar alignment quickly and using my laptop. It's on a Losmandy G11 mount. I have what's called an on-axis guiding port. It is I use instead of second camera and guiding scope. I use an on-axis guiding port instead. It's not an off-axis; it's an on-axis. You'll have to look up that and look at the details on the on-axis guiding port from Innovations Foresight. It's an intriguing and interesting method for doing guiding, and I'm not going to go into that in very much depth. And then I have an Optec electronic focuser. This does not include any of my visual telescopes, which I also have. This is just my imaging scopes. Here's an example of the original 071 camera. As you can see, there's a fan on the back that keeps the temperature regulated by the Peltier cooler that is on the chip itself. It has a USB 3 output to go to the the computer, and then two USB inputs so I can daisy chain USB devices that are on the scope itself, which is very handy so I don't have as much cabling. This happens to be the Focus Links focuser system I use from Optech, just to show you all the components. There's a control box and then some adapters and some cables, etc. I'm using that using a Ethernet connection, so it's powered by Ethernet, power over Ethernet, and it's also communicated via Ethernet. This is how I've got the observatory set up. There's a computer in the observatory. This right here. It has an Ethernet cable to the local router, and it's wireless to the mesh network that I've got set up. And this bridges both the observatory router network and the house network. You have the pole master hooked in USB. UPS is hooked up USB. This is the telescope mount and the focuser via Ethernet. And then all the other cameras are via USB to the observatory computer. That observatory computer is just a little $350 B-Link computer. It's like a microprocessing computer. Nuke makes them, etc. But everything is Wi-Fi to the mesh network in the observatory out to the house router, and my house computer, which I'm sitting at right now, is how I run the. I don't run the system from the house. I monitor the system from the house by using a remote desktop to this observatory computer. And the primary control apps are a thing called Sequence Generator Pro, PhD2, and Focus Lock. So here's some examples of some of my deep sky astrophotography. This is one is with the 105 millimeter refractor of the open cluster within the Rosette Nebula, and the Rosette Nebula happens to just be there. And this is using the ASI 2600 MC Pro camera. Oops. This is the Cocoon Nebula. This is using my 071 Pro with my 300 millimeter lens, piggybacked on that 10-inch. And that's 4 hours of data. This is the Flame and Horsehead with the 105 millimeter refractor and the ASI 2600 Pro camera, 3.5 hours of data. This is M8 and M20, the Trifid and Lagoon Nebula with the 300 millimeter lens and the ASI 2600 MC Pro camera. I'm bringing up this astrophotography cameras because these are cooled so I can hold the temperature and hold the noise floor constant so that my dark frames are valid for subtracting out the noise that's in the chips. And so this is what you can accomplish with a astrophotography camera, regardless of what lenses you're using or telescopes. Lots of nice dark lanes in there, and lots of nice red, which is not so prevalent with a DSLR, an unmodified DSLR. Let me rephrase that. Again, here's that M31 shot. Here's the Pleiades with that 105 millimeter f7 refractor, which is basically a 735 millimeter focal length. This is 2 hours of data with 60 and 120 second subs. This is the Pleiades. Fireworks Galaxy NGC 6946. It's a 10-inch f8 RC, 6 hours of data with the 071 camera. The Eastern Veil. This is 5 hours of data with a 105 millimeter refractor and the 2600 MC Pro camera. Interesting. Remember I had that North American shot with the DSLR and there wasn't a lot of red in it? Well, this is what you'll get when you have a camera that's more sensitive towards the red. You'll get some nice hydrogen. My processing, I don't stretch it as far as a lot of other people do in general. But here's an example of stretching the Iris Nebula quite a bit. And the reason I did that was to show all this dark nebula and all this background dark nebula that's part of this area. This again is with the 105 millimeter refractor. 9.5 hours of data at the Okie-Tex Star Party um, with the ASI 2600. M66 in Leo. This is 4 hours of data with the 10-inch RC. NGC 891. This is three hours of data with a 10-inch f8 RC. This is using the older camera, the MC 071 rather. And here's the Deerlick group, 5 hours of data with the 071. These are all five. Most of these are 5-minute sub exposures, stacked a whole, many of them. This would have been 60 frames stacked at 5 minutes each. This was an older one I took back with the M51 Whirlpool, again with the 10-inch. M31 with the 105 millimeter refractor. I'm sorry, M33, not 31, M33. A little brain fart there. The other thing I like to go after is Abell galaxy clusters. That's what this is here. It's a Abell 2151 galaxy cluster. There's 8 hours of data on this with the L71 camera. One of the cool things you do in PixInsight, if you do this, is you can plate solve it and find out there's all these other little galaxies in that field of view. So there's the raw data, well, the process data, and there's the plate solve of what's in there. All the blue and red are galaxies, and the yellow are stars. So that's kind of fun to do that. I also do some solar work with my 6-inch f10 SET and my white light filter. This was from February 8th and 9th of this year. Some interesting sunspots. And then this is from April 21st. Very nice grouping there on the sun that I also took with that 6-inch. And I use different software for this. I use a software called AutoStacker 3. What it does is it analyzes the video that I take, which is an AVI video. It analyzes each frame of that video and determines the best to the worst frames in terms of clarity. And you just pick the best 10% or the best frames and process them. You throw all the rest of the video away. And the reason you do video is the turbulence in the sky is scintillating. You'll get moments of good seeing once in a while. And it actually, if you're lucky enough and the video's fast enough, you'll grab some of those nice little clear seconds. And you end up getting the ability to do something like this. After a while, you accumulate a bit of data. Here's a little bit of my portfolio on my Flickr account. So that's all I got. So any questions at this point, feel free to open up and ask or type in the chat.
And Doug, if they're at the Nature Center, they'll need to get the microphone.
Okay.
Oh, hey, Doug.
Yeah.
This is John. Hey, when you start out going for a target, how do you decide like which camera you're going to use?
That's kind of based on the size of the object. So a lot of the galaxies, I'll use the longer focal length telescopes, like my 10-inch f8 RC, which is approximately 2,000 millimeter. This guy right here. This guy right here fits pretty nicely in that scope with that camera. But you can also do. I actually have taken this object with my refractor, but it's a lot smaller, and so the resolution may not be as good. If you're doing wide field stuff, again, depends on what area, how much area do you want to capture with your camera / lens or telescope system. In fact, I'll give you an idea. This is a very small field of view here. These galaxies are really tiny. I wouldn't bother with my 10 millimeter lens to go after this area of the sky. These would be almost imperceptible from stars because this is with the 10-inch. This is basically a 2,000 millimeter telephoto lens with my 10-inch. So it really depends on what you want to go after. So Mike Lutton says, hi, when using a camera lens, do you stop down the aperture? Also, how do you choose the ISO? Okay, so normally I do not stop the lens down. I usually leave it wide open, which gives you other artifacts possibly off the lens. If it's not a high quality lens, you can get a little bit of coma around the edges, etc. But you really want to gather data as fast as you can in this shorter period of time. So the ISO, my wide field stuff is usually ISO 1600 to 6400, and it's wide open. And unless I'm on the tracking mount, in other words, I'm just on the tripod, not tracking, I don't want to go more than 20 seconds with any setup on that simple as setup. So I want to get that as much data in as quick as possible. So an f2.8 would be a lot better than an f7. However, if you want to, I have taken the Venus Pleiades shot I took at f7 with that camera lens because I wanted to get that starburst on Venus as an esoteric artistic item. So, but generally just wide open to get as much data as you want.
John, does that answer your question?
It does for me.
Okay, well, we'll take one from the Nature Center. If you can identify yourself.
Keith Cisco. Hi, John.
Hi, Keith.
Curious, when you do the original capturing, do you use filters, or is it all the colors brought out in the processing?
So whether it's the DSLR or the one-shot color astrophotography cameras, I do not use any filters except I may put my UV IR cut filter in place to keep the infrared in the ultraviolet off the lens. But otherwise, because their focus points are a little different than your primary white light. So you may use a UV IR cut filter for the purposes of good focus. But if you want a little more of the IR, you take that filter off. Otherwise, I don't use any of the narrowband filters or any other filters for my image process, my imaging, because I'm using a one-shot color anyways. And I could use like the L Enhance or the L Extreme, even with the one-shot color, in order to cut things like the lunar glow and during a full moon down. But I've not bothered to do that yet.
Any other questions from the Nature Center?
I want to say thank you. Very good.
Our test worked real well here.
Oh, good.
Thank you very much to you guys that are not here.
Did you save me any donuts?
I think we finished them all already.
Oh, okay.
Any more questions? Going once. Okay, well, Doug, thank you very much for another fantastic presentation. Doug and I will arrange somehow to get this posted on YouTube. So that'll be the end of our presentation this evening. If you'd like to stick around and chat, then you're more than welcome to do that in the Nature Center or whether you're online. So thank you very much to everyone for attending.
Thank you for inviting me. Enjoyed it.